in specific cases, or it's legally restricted, like in the healthcare use cases. Protections like HIPAA or GDPR prevents us to actually use the data. And this is where synthetic data comes in. Synthetic data means that this is generated data that is statistically close to the real data. So we would need some input of data that is real data, and we can enrich that and extend it with some synthetic data that is statistically the same. So we preserve patterns, we preserve anomalies, etc., etc. And today I'll be talking about one specific tool of doing that, and that would be SDV, or Synthetic Data Vault. That's basically a collection of machine learning algorithms trained to work with different data sets. I won't go into much depth here. SDV is huge. I'll go through the most used synthesizers, the general flow, how this is used, just to have it in mind how that works. And first of all, we'll go through a simple toy example about generating student performance data. And let's look through the code here. I have it open in a Jupyter notebook. Notebooks I can provide to anyone. If anyone's interested, just feel free to ping me. And here what we have, standard imports, nothing fancy. We have a simple data frame that shows three specific values for each student: their math score, their reading score, and their hours studied. So there is some statistical connection between these, and we want to generate more data that looks like this. And how does usually SDV work? We generate metadata, and there are a few classes that help with this, but here will be used the single table metadata. I'll show others in a bit. And this metadata, we can just detect it from a data frame. So this is fully integrated with pandas or powers, because powers covers the same API as pandas. And then we create a synthesizer. Today, this will be the Gaussian copula synthesizer, which is great for like single table data. Imagine flat data. And after that, we just sample 100 samples of this data. If we run that, we get data that looks like the one that the data we provided. And this is how generally SDV's flow works. We feed it some data, we detect metadata from that, and train a model by it. In this case, the Gaussian copula model. And now to a specific case. In healthcare, healthcare is one of the biggest fields of actually progress in the AI department, because AI models can be used for early diagnosis, for actual finding new drugs for for specific diseases, etc., etc. And the biggest issue with data for training AI models in healthcare, that's privacy. Usually healthcare data is related to patients, and that's covered under HIPAA or GDPR in the European Union. And it's not easy to actually get this data and to work with it. Here, for our example, we'll have a multi-table data set, meaning relational data. We have three tables here in this example. The patient's table, which has an ID, age, gender, body mass index, and smoking status. This is some specific fields that can be used, but we can extend this as much as we want. We'll have medical history table. Again, we keep the patient ID because we'll be using that for the relationship between the tables. The diagnosis, number of visits, and average glucose level, just to have that in there, because diagnosis could be diabetes, for example. Here we can extend this with blood pressure or blood oxidation and other stuff. And the medications table, which again has the patient ID, which we use as a foreign key here, the medication name, dosage, and from the date which is started taking it and the date the patient stopped taking it. Such data can be used to actually see some interesting connections between some medications acting on other diseases, not the ones that they're specifically created for. And again, we'll take a look at the code example. Here we have the three data frames simulating the three tables we have with three patient IDs. Imagine here that maybe there is a first name and last name, and in order to actually make that data anonymous, we can just tell SDV to generate anonymous names. It can anonymize the initial data or the synthesized data. And here we, again, detect metadata from the tables the same way. We just run it to multiple tables. And an interesting point here, because we'll be using the patient ID column as a type, we have to set that type. So that's one really specific thing for SDV, which is that it has its own type system. So we need to cover that so we can actually create the relationship between the between the tables. And that's what's going on here with the add relationship on the metadata. Imagine like the metadata is the relationship between the data and the specific data points in it, and SDV is extracting that for us. And a good thing here is to save the data, the metadata to JSON, because if you imagine if you have a huge data set, actually extracting that metadata will take a lot of time, but we can save that, and SDV can use previous metadata for training a different, let's say, a synthesizer, or retraining the one we are using. And after actually dealing with all the metadata, training the model is really two commands. And here you can see that we are using a different synthesizer, the HMA synthesizer, that sorry, that's usually used on related data or multi-table data. So rule of thumb is HMA synthesizer for relational data and the Gaussian couple for single table data. But as I said, SDV is a huge tool. It has many options. These are the most used. After we train the model, exactly the same way, we can just sample the data and we can generate. Here you can see we can synthesize data for each table separately. So we can get patient data separately from medical history data or medication data. And this could be useful in many ways in the healthcare field. Moving on to the next use case, which
sorry, I have a question about a medical example. Can I ask?
Yeah, of course.
Yeah, I wonder if this synthesizer can produce like invalid combinations of, for example, dosage and medication, something like that, or it's smart enough to like, follow the patterns of the input data.
Okay, there is two things here. So usually if we do this straightforward as I did here, for an example, it is possible to generate what you say, let's say a 1 gram dose of metformin. It is possible, but we can additionally feed this metadata with some specific constraints, let's call them. So we can say this field for this combination cannot be, has to be between this number and this number. So to fill up this use case, we would have a fourth table to be actually usable in the real world, which will be like these dosages you mentioned. So yeah, great question. Yeah, yes, we can. The model itself will not find this directly to find that this is medication, and the medication should have some specific dosages, but we can set those constraints ourselves.
Okay, thanks.
Just a quick another question. Does it take care of, am I correctly understanding that it does take care about the distribution and statistical stuff, right?
Can you repeat that? I didn't
quite
get it.
I mean that the library itself under the hood takes care of the statistical distributions of the data and so on, right?
Yeah, exactly.
Okay.
Exactly.
And sorry to interrupt you, but one more question if possible. Do we somehow define the volume of future synthetic data? So do we somewhere state how many data sets do we need to produce? To be produced?
Yes, that's in the toy example, you can see it. We have this sample call, and we say generate 100 samples.
Okay, thank you so much.
And if we don't say a specific number, it will use a default value, which I don't see that it's set. There used to be a default value for this number of rows.
Thank you.
But yeah.
Yeah,
we can limit it.
Sorry for jumping in. One more question. Just to clarify, these methods, synthesizers, are using some kind of complex interpolation, extrapolation, some kind of this mathematical methods, and it doesn't matter which data we are giving them, just to clarify. And to add for the first question, how this data will be enough to study the model on this synthetic data if it's based on, I mean, in medical sphere, in healthcare sphere. Thank you. I hope you understand.
Okay, so each of these synthesizers is basically a machine learning algorithm, which is pre-trained, and we just fit the data into it. And depending on the use case, maybe the HMA synthesizer won't be the best choice for this, or the single table Gaussian couple won't be the best case. I'm using those as they are the most straightforward to actually demonstrate the library itself. But again, this does not exclude the data science part of this. So all the data needs to be checked, validated. I'll touch on that in the end when talking about some pros and cons of synthetic data. But yeah, we should keep in mind that this is statistical models. Those are not they are not specific for a use case. So the HMA synthesizer will work with any relational data. So we need to keep that in mind when actually synthesizing data with those.
And one more question, sorry to interrupt you again. Are these models only applicable for the table data or also to some, let's say, images, not the text, but something else? I mean, for computer vision models, etc.
This is more suited to actually to table data. So
Thank you.
yeah, maybe in some way you can actually show the visual data as table, but to be honest, I haven't tested the case, so maybe it works, maybe it doesn't.
What about natural language synthetic data?
Not really sure about this. This is more specific to actually statistical data. So
okay, understood.
yeah.
Thank you.
Yeah, maybe they will extend the whole SDV because it's in constant development. SDV is in constant development, but these are the use cases I've used it for generating statistical data for some use cases. As for natural language, that's the biggest problem actually at the moment. So how do we get data to train all of these great models? So yeah, and I'm not sure synthetic data will help there at all. So.
I suppose yesterday at the not training but the presentation regarding the generative AI trends 2024, the presenters, they told something that actually synthetic data is expected to help with those LLMs, but maybe I'm mistaken.
Yeah, maybe that's the expectation, but the current state, at least to my understanding of synthetic data generation, might lead to actually dumbing down the Gen AI models.
Thank you.
Yeah, but yeah, my knowledge there is limited in the Gen AI use case of this, so I might be wrong. Maybe that's the future. Okay. So moving on to the next use case, and that's retail. So imagine there is a company that's launching a new product and they want to like simulate market demand for it or pricing strategy, so on, but they do not have data for this product. It's basically brand new, but they have transaction data for other products which are either in the same category or in the same price range, etc., and that can be used actually to predict a bit in some way the demand or pricing, etc. And here we again have a data set which is pretty straightforward. We have transaction IDs, customer IDs, which can be anonymized, the customers themselves, but product categories, dates, the amount of the sale, and if any discount is applied. And we have this here in a single, defined in a single table, which is this data frame here. And again, again, here's something pretty normal. We convert the datetime field to actually datetime type for pandas. Again, we generate the metadata, but the interesting part here is that we need to accept telling pandas that this field is a datetime. We need to tell SDV as well that this column order date is of its type datetime and the specific format it expects. So we need to do this a couple of times for the two libraries we use here. And after that, we do the same thing and we save the metadata for later. And as this is a single table, even though we do have some specifics like the order date, we again use the Gaussian copula method synthesizer. And here, another example for the sample size, I set 1,000 here. Maybe I want 10,000. The synthesizer itself uses a generator under the hood, so and we can actually play with the batch sizes of that. So don't worry too much about timeouts or memory leaks, etc. Yeah, pretty straightforward again. The whole idea is to show that SDV uses the same flow, get some data, extract metadata from it, train a model, sample data from it. Here, the complexity comes, as we already spoke about, from the use case itself. So do we have some constraints? Do we want to anonymize something? But the tool itself is pretty straightforward to use. And the last use case we'll touch on today, that's the smart city use case for simulating traffic data, because traffic data is pretty hard to get actually, especially for bigger cities where there is a lot of traffic and there is a lot of streets, avenues, and it's really, really costly to get a full picture of how the traffic actually works. And also random events like accidents are really hard to capture and simulate even so. And we don't want to simulate traffic accidents, of course. So again, that's a good use of synthetic data. I won't go into much detail. The flow is the same, basically. And just here, the data set is the interesting part is that it's a time series, so hour of day on a specific place. So we can simulate traffic through a specific crossroad, let's say. And again, we have the traffic data, we have some conditions like what's the speed limit, what's the weather, number of accidents, how many cars pass through in an hour, and which hour. And we just update the columns with the SDV types and save the metadata. Nothing actually we haven't spoken about, is just a different perspective on how we use SDV. And finally, actually what we spoke about, what are actually the pros and cons and best practices in using synthetic data. So the main challenges is generating realistic data, which is actually the biggest thing in generating data usually, and that's like this specific thing that you mentioned, like we did not take into account the dosages of the specific medications. That would lead to unrealistic, poorly modeled data that would later create some unrealistic pattern for our AI models, which could be really hard to actually catch. So yeah. Bias amplification, that's another issue that's been plaguing the machine learning community for years. If your data is initially biased towards something, synthetic data will inherit that. So this is not fixing bias amplification, but if the initial data is unbiased, synthetic data will be unbiased. Overfitting, another problem. Models will memorize data instead of generating new data that's statistically the same. And one specific point about synthetic data, and that's validation. How good, how statistically similar is our synthetic data to the real data? So that's something that we always need to keep in mind, that synthetic data needs to be validated for statistical similarity to the real data. SDV provides methods for that. That's the evaluate method, which just gives us a simple number, how similar is the data. And any number over 95% is usually considered good. Best practices, we spoke about a bit of that. So selecting the right model for the data we have. Again, these two examples, the Gaussian couple and the HML synthesizer, those are the two most used models, but there are others that have more niche use cases. SDV actually has great documentation. It's based on Jupyter Notebook, so you can just try some things there and so on. And here I mentioned that hybrid data sets are usually used. So we enrich already existing data set with some synthetic data, and for best results. So we don't use purely synthetic data for training models, because that could lead to issues with overfitting, bias, etc. And we always need to keep in mind compliance for privacy, especially legal reasons. So yeah, key takeaway here is that synthetic data is a thing that can be used to help help train AI models, and SDV is a great library that we can use to generate data. Years ago, we used to create some big scripts with the Faker library that generates something that we think is synthetic data, but SDV actually collects all of that and puts it into one good reusable package. So, any further questions on the topic?
May I ask a couple of questions? By the way, very great presentation, Vladislav. I'm Evgeny from Big Data Analytics Group's GCP cluster. Our use case is that we need to generate some synthetic data for manufacturing project to create some demos, and the data should be streaming data from production equipment sensors. Do you think that this tool will be useful in this case? Does it allow to set, for example, trends for time series data, like if we have values in this range, the value should grow, then it reaches a certain level, it should generally go downwards. And can we set some dependencies between a couple of streams? Like if, for example, production line stop sensors generates data, then some other sensors should be should stop producing data until another event occurs or something like that.
Yeah, I don't have a direct answer, to be honest, for you to tell you yes, it can do it or no, it can't. But I can take a look and see if it can cover such case. If you want, you can ping me later, and I'll take a look.
Okay.
Try to
Maybe earlier next week.
Yeah,
if you
yeah,
have time.
of course.
Thank you.
Yeah, of course.
Next question: have you used other libraries and tools which generate synthetic data, and how this one compares to those?
Okay. Honestly, I played around with a couple of other libraries, but this one is the most comprehensive. So, yeah, as I said, you can use Faker to build something, or you can use TensorFlow, for example, to build some data set, but that's a bit harder to actually use. You waste more time actually generating the synthetic data instead of actually training a model or finding a solution for the real problem. So yeah, there are other libraries, but this one is, at least to my opinion, the easiest to use.
I would also recommend to look at this one, if not yet. It's Databricks Lab data generator. It uses Spark with some. Basically, you define the structure for the resulting data frame rules. It can, by the way, also use Faker under the hood for certain fields. And it can generate very large data sets, and it's not linked to Databricks only. You can use it locally with Spark.
Oh, cool. Yeah, thanks for the recommendation. Yeah, that's useful.
Yeah.
Okay.
Okay, thank you, Vladislav, for such a great presentation. Thank you for sharing your experience. Thanks, everyone, for joining us today. I hope to see you on our next events. You will receive a feedback form shortly. Please fill it in. Your opinion matters for us. Have a nice day. Take care. Bye-bye.
Thank
Thanks,
you.
it was
Thank you.
useful.
Thanks,
Bye.
Thank
Yeah,
you.
bye.
Bye bye.